orbital energy diagram for argon minus. Argon minus. Which one did I just do? Oh, I did silver plus. Let's change that to zinc minus. It's got a nice big one here. And just for fun, we'll do all energy levels. So no noble gas core. And that way we'll really be able to see how the N values go. So here's my big energy arrow. We'll start by doing the electron configuration for zinc atom. And again, you don't have to do it this way. This is just sort of my way of doing it. It goes 1s2, 2s2, 2p6. And we're starting on the periodic table in the 1s area, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. That's the atom. Now we're going to change that for the zinc ion, the zinc minus. And for the zinc minus ion, we're going to add 1 electron. There's nothing to do except put it into the 4p area. And we know it's 4p. Maybe I haven't talked about this. The 4 S's and the 4 P's are always directly across from each other. It's only the 3 D's that are one behind. And I guess I haven't talked about this, but you can see this is the 4F area, and 4F fits in right here. After 56, you go down to 57. Anyway, the ion just adds the 1 electron there. And let's see. So now let's do the whole thing. So we'll start with 1s, 2s. Each gets 1 box because there's 1 orbital. 2p. 3s. 3p. And you can fill in your arrows as you go. Aha. Now 3d. Because it's always the 1s, then whatever 2s you have, then whatever 3s you have, then whatever 4s you have. And I almost ran out of space, but we're going to squeeze it in here. And the 4p still has 3 orbitals. You still do typically draw all the orbitals, even though there's only 1 electron that's going to go in there. And now I'll put in my electrons. 1, 2. 1, 2. 1, 2, 3. 4, 5, 6. And I really do, in my head at least, always count these out. Like my soccer coach used to say, even though this is not the exam, practice like you plan on playing. Always put those 1 electrons in each box before you ever pair the electrons. All right, so we're up to 4s. Yes, the 4s does have 2 electrons in it. And then 4p only has 1. So you put the last one in there. And for an electron configuration of an element like gold, does it take an electron for S or F? Let's go ahead and do that one too. Although first off, any questions about this one? Or was so hopefully that was what you're looking for. If not, we can do more.
Yes.
Yeah. All right. So now let's do the electron configuration for gold atom. And then we can talk about how to do it for the gold ion, either positive or negative. So the gold atom, 79 electrons. So I'm actually going to use a noble gas core for xenon, which is 54, because I went backwards on the periodic table to the previous noble gas. So it's got 79 electrons. The first 54 are the same electrons as xenon. Let's see, good. We can fit in our periodic table. All right, so we're at xenon. You follow from 54 to 55. You see that this is the 6s area, so we're going to go 6s2. At least initially, we'll revisit this in a second. After 6s2, you hit the asterisk. You drop down to 4f. You can see that 4f has 14. Because 4f has 7 orbitals. And then we come back up. So, and you can, if you follow the numbers, it went from 56 to 57 over to 70, then back up to 71, all the way over 1, 2, 3, 4, 5, 6, 7, 8, 9. And 3D, 4D, 5D, 9. And then you say, D has 9. I think that wants 10, and you are right. And then it is one of the exceptions that we memorized. So one electron goes over here, and it actually does take it from the 6s. The reason it takes it from 6s is because that's the highest energy electron. And so this is the electron configuration for the gold atom. It is correct. You may also write it with your 4s first, then your 5s, then your 6s. And this is the order of increasing energy. So if it became gold plus, you would remove the 6s electron, and this would just disappear. If it became gold minus, you would add an electron, and this would be 6s2. So, Antonio, you may have asked me what time it is, and I may have told you how to build a clock, but hopefully it's rather more information than not enough. So hopefully that answers your question. Any other questions about this? Or if not, please ask again more questions.
Prof.
Yeah.
I don't know if I'm taking us behind. So for this 6s1, are we going to fill the box or we're going to leave it empty?
Well, okay. So if we were doing the gold atom would look like this. So we'd have xenon at the bottom. Then we'd have 4f, 5d, and 6s. And 6, 7. And there'd be 2 arrows, one up, one down in each of them. And I'll do that in a minute. 1, 2, 3, 4, 5. And then 6s. So if we're doing this one, we would have 14 arrows.
14 arrows.
Yeah. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then for the 6s1, there would be one up there.
I'm saying so because I think it's like the other one that we did, not this one, the previous one. For the 5-1, we didn't fill the box. Not this one, the one before this.
Ah, yes. So let me go
Yes.
back to that, and then Manal, I'll answer your question. Oh, there it is.
Yes.
So the reason we did not fill this box before was because we were doing this. And there was nothing in 5s. So if there's nothing in 5s, and this was because it was the silver plus ion, and when we made the silver plus, we took away this electron. But no, so if there's no electrons in it, you do not have to draw it. I don't know if that answers your question.
I'm still confused.
So if we do this electron configuration, there's one electron in 6s, so we put one arrow in 6s. If we were to do the gold plus ion, and we write out its electron configuration, gold plus has everything the same except take away the 6s electron. And maybe I can take a second and answer your question, Manal. Do we need to put it in order? So on the homework, when I ask for an electron configuration, the homework accepts either order. But when I ask you to do the orbital energy diagram with the arrow and the boxes, there's only one correct answer. And that is from having all of the n numbers increase as you go up. And so now finally to answer this, if this is the question, then we just do xenon 4f14
And 510.
and 5d10. 1, 2, 3, 4, 5, 6, 7. 5d, 1, 2, 3, 4, 5. And you do not have to draw 6s.
Okay, I understand now.
Very good. Ah, I cheated. I did them two at a time. Felt wrong. And unfortunately, I do have to fill in all these boxes. Call me anal retentive if you will, but it didn't look right there. Anyway, so you can, so on this, there's nothing in the 6s, so you can leave it off. If you were to draw it, you would leave it empty. Cool. Any other questions?
Thanks, Prof. I understand now.
Great. That's so cool.